Hello students, in the last video I explained regarding dehydrogenation, oxidation reactions. If primary alcohol is used, it undergoes a dehydrogenation using copper catalyst. It can give aldehyde. Second alcohol gives a ketone. And if it is a tertiary alcohol, that undergoes a dehydration to form alkene. Then in case of oxidation, same method, but there I told some oxidizing agents like potassium permanganate and Lucas test, and even PCC, okay, pyridinium chlorochromate. If it is KMNO4 or potassium dichromate, uncontrolled oxidation occur, then we get carboxylic acid, primary alcohol into carboxylic acid, even second alcohol into carboxylic acid on heating. But if you want to control the reaction or control the oxidation, you have to use a special reagent that is called Lucas reagent. That is said to be Lucas reagent. A mixture containing anhydrous zinc chloride and concentrated HCl is called Lucas reagent. It can be used to distinguish between primary, secondary and tertiary alcohols. And even methyl alcohol, ethyl alcohol, their preparations, methanol, ethanol preparations that we can study now, or manufacture of methanol and manufacture of ethanol. But other points already covered in the last video. And even we can study regarding denatured alcohol. Denatured alcohol, that also will cover today. Now, manufacture of methyl alcohol. See how to manufacture, how to get a large amount of methyl alcohol in the industry by taking a chemical substance, that is a CO, carbon monoxide and hydrogen, and this mixture is called water gas. It is said to be water gas. Water gas is a mixture of carbon monoxide and hydrogen, and to this extra or excess hydrogen gas is passed. Means hydrogen gas and water gas, they are compressed and passed through a special catalyst, and there are process named as Bohr's process. By Bohr's process, one can convert water gas into methyl alcohol, and catalyst ZnO Cr2O3, ZnO Cr2O3, zinc oxide and chromium trioxide. So this mixture, yes, it is said to be a catalyst in Bohr's process. It is used as a catalyst to convert water gas into methanol, and pressure 200 to 300 atmospheres, and temperature 300 to 400 degrees Celsius, or 273 plus 300, there is a 573 to 673 Kelvin. 573 to 673 Kelvin. Yes, under all these conditions, hydrogen reduce CO into CH3OH. Just to observe, hydrogen molecule adds to CO because of unsaturated nature of CO. C triple bond O. This is a carbon monoxide. This is a positive, this is a negative. C triple bond O. Okay. And this molecule is said to be unstable or less stable. Then it can undergo easy reduction to give methyl alcohol. Give equation for the manufacture of methyl alcohol or for the formation of methanol from water gas. Now with conditions you have to write, without these conditions there is no addition of hydrogen to carbon monoxide. Okay. Yes, whatever methanol is formed on large scale, and that can be used in various industries like in oils industry, fats industry, or even in paints and varnishes industry as a solvent, and also to denatured alcohol, denatured alcohol. This is also important, carrying 1 mark. Actually, ethyl alcohol mixed with methyl alcohol, about 5%. 5% methanol added to ethyl alcohol. Yes, ethyl alcohol made unfit for drinking by mixing with 5% methyl alcohol and copper sulfate few crystals or crystal violet, and it produce some color to the what alcohol. Then pyridine, a bad smelling compound, pyridine. Copper sulfate, pyridine and 5% methanol added to what? Ethyl alcohol, and now we can say ethyl alcohol is made unfit for drinking by mixing all these three. Then it is said to be denatured alcohol, and it is also used as a solvent or commercial solvent in industries. Especially in paints and varnishes, yes, such mixture is used, that is called denatured alcohol. Next, methanol also used in industry to prepare methyl salicylate, which is what analgesic. By using salicylic acid, one can prepare methyl salicylate, and that is used as a what analgesic. But to prepare methyl salicylate, we need methyl alcohol or methanol. But even in perfume industry, one can use methanol. Okay, and antifreeze, it acts as antifreeze in automobile radiators. Antifreeze in automobile radiators. There is the importance of methanol. Then same type we will study in case of ethyl alcohol, how to manufacture ethyl alcohol. It is also important, maybe in 2 mark question. Manufacture of ethanol or ethyl alcohol. See how to get ethanol or ethyl alcohol in the industries or a large scale. Hence it is called manufacture. Now to manufacture ethanol, yes, first we take here molasses. So from molasses one can manufacture what? Ethyl alcohol. There is a manufacture of ethanol from molasses. You know, molasses, it is the residue, means the last end product, residue. It is obtained during crystallization of what? Sugar from sugar cane juice. That's why it is also said to be mother liquor. Mother liquor left behind during crystallization of cane sugar from sugar cane juice. And this mainly contain what? C12H22O11. This is sucrose or cane sugar. This is present in molasses. Means you are going to convert sugar into alcohol by the action of enzymes. Hence it is also called as alcoholic fermentation. By alcoholic fermentation process, yes, we can manufacture ethyl alcohol. Then molasses first diluted with water, then mixed with some amount of yeast. Yeast added in diluted what? Molasses. Next, this contain 2 enzymes, invertase and zymase. Invertase, zymase, these enzymes present in yeast. So as a yeast here we can add in the tank. Then a small amount of what? Acid like sulfuric acid also added. Then the mixture is agitated or stirred well and kept for about 2 to 3 days. And by closing it, it is kept for 2 to 3 days. And in these hours, maybe 36 to 48 hours, fermentation takes place. There is a conversion of sugar into alcohol takes place in 2 stages. And in stage 1, you have to explain how sugar changed into glucose fructose, and stage 2, glucose fructose into ethyl alcohol. Now we write 2 equations, but both the equations important. conversion of sucrose to glucose fructose and glucose fructose into alcohol. C12H22O11 plus H2O in presence of enzyme invertase. In presence of enzyme invertase. So invertase is the enzyme present in yeast which can catalyze hydrolysis of sucrose. Hydrolysis of sucrose which is present in molasses and is converted into what? C6H12O6 plus C6H12O6. So in a biomolecular topic we can study structures of all these, but glucose aldehyde molecule, fructose ketonic molecule. This contain CO group, there is ketonic group, and here CHO aldehyde. But they have same molecular formula, differ by functional group, hence they are said to be functional isomers. Anyway, when sucrose hydrolyzed we get glucose and fructose. Sucrose hydrolyzed we get two compound, glucose and fructose. This is stage 1. Then in stage 2, see what happened. C6H12O6 zymase enzyme. Glucose and fructose undergo decomposition by the action of enzyme, or it is catalyzed by the decomposition catalyzed by enzyme zymase. It is also present in yeast, and they can convert C6H12O6 into C2H5OH and CO2. Now it is said to be ethanol or ethyl alcohol. Now balance the equation. Here 6 carbon, so better write here 2. 4 carbon, 2 carbon, 6 carbon. Tall H, 6 into 2, tall H. And O6, 2 plus 4, 6O. Yes, these are the two reactions or equations to write in manufacture of ethanol from molasses. Okay, first you define what is molasses and what it contains, and write in brief regarding procedure, and compulsorily you have to mention 2 equations and each carry 1 mark. Okay, like this one can convert molasses into or sucrose into ethanol. Now at this stage we get only 10% ethanol. 10% ethanol. Whenever ethanol is formed about 10%, 11%, 12%, immediately it can be removed from the tank. Otherwise, its percentage goes on increasing 11, 12, 13, 14, 15, 16. If a percentage of alcohol formation exceeds 14%, if more than 14% alcohol is present in the tank, and that cause what activity of enzyme is decreasing. That cause what enzyme activity, it may be zymase or invertase, then its activity what decrease, and to maintain activity of the enzymes, yes, here percentage of alcohol should be less than 14%. Then once you remove alcohol from what the tank, and that is subjected to fractional distillation. After fractional distillation we get 95.5% ethanol and is said to be what rectified spirit. Further distilled with calcium metal, then we get or calcium oxide or what lime, we get 98% alcohol, that is said to be lime alcohol. And finally distilled with calcium metal, then we get 100% pure ethanol and is said to be what absolute alcohol. But first important preparation of 10% alcohol, that is called wash or wort. That is said to be wash or wort. But in the tank you can see there is a formation of a scum. At the top there is a formation of scum, and that scum due to what liberation of CO2 gas during fermentation, alcoholic fermentation. liberation of CO2 occur as a byproduct here, liberation of CO2, and that causes scum in the tank. But that scum is formed due to liberation of CO2, O2, N2 and Cl2. So answer is liberation of CO2. Okay. Next, once you get ethanol, ethyl alcohol, then think about the use. It can be directly used in the manufacture of what? Alcoholic beverages like beer, brandy, whiskey, etc. Also used as a solvent for oils, fats, resins. In hospitals as antiseptic. In hospitals as antiseptic. And to prepare perfumes, there is in the perfume industry, one can use ethanol. And as a solvent for paints, varnishes, and even wood polish, etc. Now, there are many applications of what? Ethanol. Yes, this is about ethyl alcohol, methyl alcohol or alcohol topic. Next, I will tell you regarding the structure of three compounds, alcohol, phenol and ether. Then we can study a new topic that is said to be phenols. Up to this I covered what? Alcohols. Now we can draw the structures of alcohol, phenol, ether. And in the previous videos I told the structure of that is a compound alcohol, phenol, ether, only formulas. Now we will study structures. In all the cases we can write like this. Oxygen is common. For alcohols, take example, methyl alcohol. Two lone pairs of the oxygen in case of alcohol, and its bond angle found to be 108 degree 9 minute. 108.9 degree means 108 degree 9 minute, and this bond length 142 picometer. 142 picometer. Bond length, bond angle, and lone pair. Two lone pairs of electrons are there on oxygen in all the three cases. This is structure of alcohol. This is alcohol. Next, in case of phenols, structure of alcohol, structure of phenol, and these are what? Bond pairs, lone pairs. For this oxygen atom is sp3 hybridized. Here oxygen sp, in all the three sp3 hybridized, right? But in case of phenol, O link with sp2 hybridized carbon. In alcohols, O linked with sp3 hybridized carbon. This is sp2, this one sp3, that is the difference. Okay. And in ethers, yes, CS3, OCS3, dimethyl ether. This is dimethyl ether, right? This compound belongs to ether series. And here also, then bond angle and here 141 picometer. Again, these also you may get in 1 mark questions or even in CET papers or in competitive exams. Just to compare the values, C-O, there is CO bond length in alcohol, CO bond length in ether, almost same. See here 140 to 141. That's a concept you have to say same. Here no resonance. Electron pair, bond pair, they are not resonance stabilized. There is no delocalization. Here also no delocalization of electron pair and bonds. There is sigma bond or pi bond. But in case of phenol, electron pair on oxygen that get delocalized, undergoes delocalization, and because of delocalization we can write yes, CO bond in phenols. CO bond in phenols. Yes, it has a partial double bond character, but in ether and alcohol there is no partial double bond character. That's why bond length in phenols is less. CO bond length in phenol is less than CO bond length in alcohol or CO bond length in ether. It is due to, or why? Questions are due to means in objective type. Why means it is in theory paper. Yes, you have to write answer. In phenol, electron pair or lone pair of electrons on oxygen undergo delocalization with pi electrons of benzene ring and undergo resonance. Due to resonance, carbon oxygen bond or carbon oxygen it has a partial double bond character, and double bonded carbons double bonded or C double bond O or C double bond C triple bond C. If it double bonded triple bonded, bond length decrease, means force of attraction increase. Therefore, in case of phenol, bond length is less. CO bond length in case of phenol is less due to resonance and due to partial double bond character and due to undergoing resonance. Next, in case of alcohol or ether, there is no resonance, there is no delocalization, hence they have bond ends are almost identical, right? Identical. Next, think about the bond angles. Actually, tetrahedral angle, like single bonded carbon, single bonded atoms, but usually in the carbon or alkanes, H, 109 degree 28 minutes. Here almost equal on 109, but slightly less value. The bond angle in alcohol and phenol, yes, they are slightly less than tetrahedral angle. Now think why here slightly less value. So because lone pair on oxygen interaction are repulsive interactions. If a lone pairs are nearer and they exert some repulsive force, if repulsion occur, then bond angle decrease. Therefore here, because of repulsive force of a lone pair of electrons or repulsive interactions of lone pair of electrons on oxygen, yes, slightly the value decrease. But here you have to say there is a question carrying 1 mark. Bond angle in alcohol is slightly less than tetrahedral angle. Why? So answer is in alcohols, lone pair of electrons on oxygen, they have repulsive interactions. Because of that reason, they have less bond angle. Next, same type here in case of phenol, same reason you write in phenol, but here slightly different. In case of ethers, see about the bond angle, ethers bond angle. Normal angle 109 degree 28 minute. If it is tetrahedral, this is also tetrahedral. Okay. Next, it is now consider oxygen at the center and like this. See here, oxygen at the center. This type. It is having a tetrahedral what geometry? Two lone pairs, two bond pairs, but bond pair linked with bulky alkyl groups. They are linked with bulky alkyl groups. Here, no doubt there is a lone pair repulsive forces are there, or interactions are there. But bulky alkyl groups are there, means large groups which are linked with oxygen. So here you have to say answer what, why this bond angle in ethers found to be slightly higher than what normal angle. So reason, in ethers oxygen atom linked with what, two alkyl groups, and they are bulky alkyl groups, and hence they exert some repulsive forces. These exert repulsive forces compared to what, repulsive forces of lone pair of electrons. Therefore, because of repulsive forces of bulky alkyl groups, what, they have a slightly higher, there is a bond angle, higher bond angle compared to normal angle. So like this you can write in one more questions. Don't draw structures etc., but write in words, maybe alcohol, phenol or ether. Okay. Next topic we will study, that is called phenols. At the end I will explain regarding ethers. Okay. Here I told the structures of alcohol, phenol and ether. Alcohol, phenol and ether. Next, phenols. So these are also group of organic compounds and they can be indicated by the formula. Yes, this is a benzene ring or aromatic system or aromatic ring. It contains carbon, hydrogen, CH, 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 CH. If hydrogen atom of aromatic ring, hydrogen atom of aromatic ring replaced by hydroxyl group, H atom of aromatic hydrocarbon like benzene, naphthalene, anthracene, phenanthroline etc., but they have benzene rings. But H atom of benzene ring replaced by hydroxyl group, then only the molecule is said to be phenol. Okay. Then now we can define what are phenols. Hydroxy derivatives of aromatic hydrocarbons. Hydroxy derivatives of aromatic hydrocarbons, in which the hydroxyl group directly attached to the or linked with sp2 hybridized carbon of aromatic ring. sp2 hybridized carbon of aromatic ring, or OH group directly attached to carbon atom of benzene ring. OH group directly linked with carbon atom of aromatic ring or benzene ring, and such molecules are said to be phenols. Then phenol application, use of phenol. Yes, simplest molecule in phenols is phenol. This is phenol. Ring with one OH group, it is called phenol. And if I write any other group along with OH on benzene ring, it is not what, phenol. There may be cresol, nitrophenol, okay, and resorcinol, different compounds are there. But if one OH benzene ring, that is said to be phenol. It is said to be phenol. Then application of phenol or use of phenol. Right? Why to study this topic you come to know, use of phenol. So it is one of the important organic compounds used in various industries. Take example, preparation of antiseptics, example Dettol. Dettol. It is widely used as a antiseptic, even disinfectant. And Dettol formula OH CS3 CS3 Cl. This is called Dettol. 4-chloro-3,5-dimethyl phenol. 4-chloro-3,5-dimethyl phenol. That is called Dettol. Or chloroxylenol. It is also said to be chloroxylenol. So this is a derivative of phenol, because again here one OH group and benzene ring. It is obtained, this compound obtained from phenol, correct? But itself acts as a antiseptic and disinfectant. About antiseptic, disinfectant, with structures, all these we can study in chemistry and everyday life topic. So other application of phenol. So this can be used as a preservative in ink, and to manufacture picric acid. And picric acid, which act as explosive, that act as a explosive. Then it is also used to prepare cyclohexanol. If you remove by double bonds, then we get cyclohexanol. And cyclohexanol obtained from phenol, but that is used as a solvent for rubber. Okay, cyclohexanol. Then other applications, it is also used in perfume industries to prepare esters. This one, phenol. And bakelite, you heard about bakelite. Bakelite is the polymer of phenol and formaldehyde. Phenol formaldehyde resin, it is said to be bakelite. But bakelite is hard plastic, and there can be used in utensil handles that is made by bakelite, and even screwdriver handles, they are made by using bakelite. Like this we can indicate various applications of phenol, and also derivatives of phenol applications. Okay. Now here I told what is phenol and examples, etc., plus uses of phenol. Then how to classify phenols? Based on the number of OH groups linked with benzene ring, we can classify phenol into three types. They are monohydric phenol, dihydric phenol, and trihydric phenol. And with structures and formulas, common name, IUPAC name, all we can discuss in classification. Classification of phenols. Based on the number of OH group, we can classify phenols into three types. First type, monohydric phenols. And here examples: phenol, O-cresol, M-cresol, P-cresol. Yes, etc. But condition, only one OH present on the benzene ring. Other groups we can write, but one OH on the ring. And all these compounds are said to be phenols, but only first one is called phenol. OH ring, that is called phenol. But all these are phenolic groups because OH link with carbon of aromatic ring. That is called phenolic group. Okay. If OH link with single bonded carbon, then it is said to be alcohol. But this one, phenolic group. Okay. Second, dihydric phenols. It is called It is said to be catechol. Catechol. Afterwards, I'll give you IUPAC names. Catechol. Second, resorcinol. Third, quinol. Yes. In all these structures, you can see two OH groups present on the ring. Then these are called dihydric phenols, monohydric, dihydric phenols. Then IUPAC name I will discuss later, but see, these are all common names. I am writing common names of phenols. Then third type, trihydric phenols. Trihydric phenols. First compound OH, OH, OH. Yes, it is called pyrogalol. Ring with three OH groups, it is said to be pyrogalol. And one more, it is called fluoroglucinol. Last compound, fluoroglucinol. But these two contain three OH groups on the ring. 3 OH, 3 OH. Hence, these belong to trihydric phenols. Okay. Then nomenclature. Yes, for aromatic compounds, if the molecule contain two groups on benzene ring, two groups, not more than two, then we can use the word ortho meta para. Ortho meta para. See, when we say ortho, when the benzene ring contain OHC carbon 1. If 1,2 position occupied by groups OH and CH3, here CH3. If 1,2 position ortho, 1,3 position meta, 1,4 position para. That's why it is said to be orthocrizol. Meta, see there, orthocrizol, metacrizol. If benzene ring contain OH and CH3, two groups on the ring, that is called crizol. That is said to be crizol. But crizol IUPAC name. Write the IUPAC name of O-crizol. Then you write 1,2 methyl phenol. Because phenol itself is IUPAC name. You can use the word phenol as IUPAC name. Okay. 2-methyl phenol for orthocrizol. Then for metacrizol, 1,3 position. If this is 1,3 position, this is called metacrizol. 3-methyl phenol. Last one for paracrizol, 4-methyl phenol. Give the IUPAC name of paracrizol. So right answer 4-methyl phenol. Then for dihydric, trihydric, yes, don't say here ortho meta para, because both are same, OH, OH, phenolic, we cannot write ortho meta para. There you can write numbers 1, 2, 3, 4, 1, 2, 3, 1, 3, 1, 4, 1, 2, 3, 1, 1, 3, 5, like this numbers we can write. If two different groups are present, OH, NO2, OH, Br, different groups are present, then we can use the ortho meta para. And here same group repeat, don't use ortho meta para. Now number system for catechol, it is said to be catechol, a common name. And for IUPAC names here, this compound named as benzene, that like CH2OH, 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 CH2OH. Common name ethylene glycol, but IUPAC name ethane 1,2-diol. But here I am using word ethane. Ethane 1,2-diol. Same type. First you say benzene. Benzene 1,2-diol. all, 2 times. So there is diol. Benzene 1,2-diol is catechol. Next. Benzene 1,3-diol is resorcinol. Benzene 1,3-diol is resorcinol. And benzene 1,4-diol is quinol. Benzene 1,4-diol is quinol. Next. For trihydric phenol, same method. What is pyrogalol? Answer. Benzene 1,2,3-triol. Benzene 1,2,3-triol. Next. Fluoroglucinol. IUPAC name. Benzene 1,3,5-triol. Benzene 1,3,5-triol. Yes, here I covered what is phenol and how to classify phenol. Yes, how to classify phenols. Yes, how to define phenols? These are the derivatives of aromatic hydrocarbons obtained by replacing one or more hydrogen atom of the benzene ring or aromatic ring by hydroxyl group. Or you can also define hydroxy derivatives of aromatic hydrocarbons in which the hydroxyl group directly attached to the sp2 hybridizer carbon atom of aromatic ring or benzene ring. There is said to be phenol. Then classification of phenol based on number of phase groups: monohydric, dihydric, trihydric. Monohydric phenol, what phenol, cresol, etc. Dihydric phenols, resorcinol, catechol, and quinol. But such examples are there even in objective type. Which of the following is resorcinol? They will give IUPAC names: benzene 1,2-diol, benzene 1,3-diol, benzene 1,4-diol, benzene 1,2,3-triol. Yes, only benzene 1,3-diol is said to be what? Resorcinol. That is called resorcinol. Okay. Next, we can study regarding phenol. About phenol, we can study. There is a preparation of phenol, manufacture of phenol, isolation of phenol, preparation, manufacture, or preparation or synthesis, then manufacture, and also isolation. Then physical property means whatever you studied in alcohol topic, same type. First, what are alcohols, how are they classified, physical property, then chemical property, their preparation of alcohol, application of alcohol. Same method we follow in case of phenols. Okay. Then preparation and manufacture of phenol and also physical property, that I will cover in the next video. Thank you.